Here we have a problem in algebra 2, that is we have to factor the given expression x to the sixth power negative y to the sixth power. Okay, in my first step what I'm going to do is I'm going to write this 6 as a product of two numbers, that is 3 times 2, and also the same thing I do with this exponent also, that is 3 times 2. Okay, now let me consider the power of a power rule in exponent, that is a to the nth power whole to the nth power. So here we have a power. So here the base is a and the exponent is m, and for this complete stuff we have exponent n. So whenever we have two exponents like this, what we can do is we can multiply the two exponents, that is a to the power m times n. Okay, so let's consider the same power of a power rule in reverse order. That is the exponent, we have a product of two numbers. So whenever we have a product of two numbers at the exponent, the first number can be taken as the exponent for this base a, and the second number can be taken as the exponent for the complete stuff. So I'm just going to use this rule in reverse order over here in both the terms of the given expression. So I am writing the first number over here, the exponent as it is, and for this complete stuff I'm going to write this second number 2 as an exponent. Let me do the same stuff for this one as well, that is y to the third power whole square. Okay, here even if I multiply the two exponents 3 times 2, I'm getting the original exponent 6. Okay, now let me consider an algebraic identity, that is a square negative b square. Actually, it's called the difference of two squares. So whenever we have difference of two squares, then it can be written in factored form, that is a positive b times a negative b. Okay, just consider the expression we have here. It is exactly in the form of a square negative b square. At the place of a, we have x cube. So here we have a square. So we have x cube the whole square. And also at the place of b, we have y cube. So for a positive b, we have to write x cube positive y cube. Let me write the stuff over here. So x cube positive y cube. I have written this stuff for the first factor a positive b. And for a negative b, I have to write x cube negative y cube. Okay, now let me consider the another two algebraic identities, that is a cube positive b cube, which is equal to, it can also be written in factor form, that is a positive b times a square negative ab positive b square. Okay, now let me consider another algebraic identity, that is a cube negative b cube, which is equal to a negative b times a square positive ab positive b square. Okay, here we have addition of two cubes. So that is we have positive sign over here. When we have positive sign over here, the first factor must contain positive sign. The second factor AB will be negative. When we have a difference of two cubes, that is we have negative sign over here, then the first factor will contain negative sign. So in the second factor, AB will have positive sign. Okay, now we can use these two identities to get the factor form of this one and this one. So because the first one x cube positive y cube is in the form of a cube positive b cube, and the second one x cube negative y cube is in the form of a cube negative b cube. Okay, now let me write the factor form of this one. For that we have to use this stuff. At the place of a, we have to write x. At the place of b, we have to write y. So let me do it. So that is x positive y times x square negative xy positive, sorry, xy positive y square. Okay, now I have finished factoring out for this expression x cube positive y cube using this identity. Now I'm going to factor this expression x cube negative y cube using this identity. So then I'm getting x negative y times x square positive xy positive y square. So this is a factored form of the given expression.